Hello and welcome to this Edexcel Further Math Statistics 1 video, Derivation of the Mean of the Negative Binomial Distribution. So at the top of this slide, just a reminder of the mean for the negative binomial, and for the proof we're going to consider the definition of EX, and you can see here we have the summation x equals r. Remember, we must have at least r events before we can have r successes. And here we have the probability function multiplied by x. And the first simple step is to realize that p and r are constants and therefore can be factorized out of that summation. So having got to this line here, the next strategy in order to obtain something that can be summed is to multiply by r divided by r. So you can see that that's happened here. We haven't changed anything, but what that does mean is that we can take the r out again from the summation sign, and r multiplied by r minus 1 factorial gives us r factorial. So now we have something here with a summation that we can actually find the value for. So if we just consider this summation and start to write out a few terms, we start where x is r, so we would have r factorial divided by r factorial. R minus r factorial is 0 factorial, multiplied by 1 minus p to the r minus r, which is 1 minus p to the 0, and I think it's fairly clear that that will just give us 1. So the first term in this summation is 1. The second term, where x is r plus 1, would give us r plus 1 factorial divided by r factorial. X minus r is just going to be 1 factorial, or 1, and then 1 minus p to the r plus 1 minus r, which is 1 minus p to the power 1. And if we divide r plus 1 factorial by r factorial, we get r plus 1. And so down here you can see the second term is simply r plus 1 multiplied by 1 minus p. And just to do one more term, when x is r plus 2, we would have r plus 2 factorial divided by r factorial. 2 factorial, 1 minus p squared. And if we divide r plus 2 factorial by r factorial, we would obtain r plus 1, r plus 2. And that then gives us this third term here. And do spend some time and have a go yourself actually writing that out and perhaps doing a few more terms. So we've considered the summation and written out the first few terms of that. We're now going to consider what you might think to be a rather strange expansion here, but something that's going to enable us to work out and get an expression for the mean for the negative binomial. And I would suggest you regard this as equivalent to 1 minus y to the minus n, and think about that expansion where y would actually equal, in this case, 1 minus p, and n is representing r plus 1. And it's worth probably spending a bit of time just on that expansion, and then you can see what happens when you actually do the expansion with the 1 minus p and the r plus 1. And if I just write down the first terms in that, obviously 1, and then it would be plus minus n multiplied by minus y, which is just going to give us r plus 1 multiplied by 1 minus p. So do just check that you're happy with that. And then the second term is going to be minus n multiplied by minus n minus 1 multiplied by 1 minus p squared over 2 factorial. And that will give us r plus 1 r plus 2 over 2 factorial, because the negatives will multiply together to give us a positive, and 1 minus p to the power 2. So hopefully you can have a go yourself and convince yourself that indeed we get exactly the same expansion using 1 minus p to the power minus r plus 1 as we do from the summation of the expression we had for the mean of the negative binomial distribution. And because we know that this summation is equivalent to this expansion here, x equals r to infinity, in this expansion here, of course, if we actually write out what we have, it's 1 minus 1 plus p, so in fact we just have p to the power minus r plus 1. And if we substitute that in here and do a bit of cancelling, we have our p to the r in the numerator, p to the r plus 1 in the denominator. If we cancel that, we obtain the mean of the negative binomial as required, r divided by p. And that concludes this section.